So very good morning to all of you. Thank you so much for taking your time out on a Sunday and joining us in today's discussion. And on the session, masterclass. This is another masterclass on BFSI Machine Learning Skill Navigator series. Today's topic of discussion, as you all know, is machine learning for risk management and modeling, and it is a real interview mock-up. So we'll discuss the topic, and then we will discuss real interview questions for machine learning related job profiles in risk management and modeling. And to present today's discussion session, we have with us Sanjay. And of course, who better than Sanjay to talk in terms of like this topic, as he has been working in both the risk management as well as like the machine learning domain, and a combined work experience in both these fields. So Sanjay, to briefly introduce Sanjay, he has done his MBA in finance and also his MSc in machine learning and artificial intelligence from Liverpool John Moores University. He also has a postgraduate diploma in machine learning and AI from IIIT Bangalore, and currently he is working as a director with the UBS in the risk modeling and analytics in risk management and control in the CRO, Chief Risk Office function. Sanjay is a risk management and analytics professional with more than 15 years of mainstay experience in risk models and methodology space, encompassing Basel, Advanced AIRB, IFRS 9, IMM, and SSCCR exposure, XVA, FRTB, OTC derivative pricing, and other advanced modeling topics. So previously, he has worked with various foreign banks, Barclays, RBS, Citi, Credit Suisse, in the risk consulting and risk management departments. And he is also very passionate about imparting practical model understanding and insights, and has been a professional trainer for corporate and investment banks. So his areas of interest are credit and counterparty credit risk, market risk, stress testing, stochastic modeling, quantitative finance, and machine learning. And I'm sure you all are eager to hear him discuss today's topic. But before I hand over the session to Sanjay, just like a brief overview of how we would go about in today's session, right? So today's session, as you all know, is like roughly about 1.5 hours, where we would be speaking on the topic for about 50-55 minutes, and then we would have the Q&A, where we will take up all your specific questions and queries regarding this topic. And since the audience number is quite large, so I mean, unfortunately, we would not be able to allow you to speak up, but nonetheless, we want the session to be interactive. And as I have mentioned earlier as well, so please feel free to type in your questions and queries in the chat window. We would be happy to take up every questions, queries during the Q&A session, right? And yeah, so with that, actually, we would like to start the session. And Sanjay, let me make you the presenter. Whenever you are ready, then you can start the session now.
Nitish. Just give me a second.
Yes, yes, surely.
Is my screen visible? Can somebody confirm?
Yes, your screen is visible, Sanjay.
Yeah, thanks all for those who have joined, taking your time on a weekend, and we would definitely like to make most of this time. And today session, as Nitish has just introduced, is basically about uh, let me maybe put on my camera. Am I visible? Yeah.
Yes, yes.
Yeah. So today's session would be on risk management, and we, as in line with the series which we have initiated to maybe talk more about how the industry is taking note of machine learning as an emerging field of disruptive uh, techniques which are disrupting not only the quantitative finance, computational finance, risk management, algo trading, high frequency trading. It is very pervasive and imminent to happen, that it will more and more so will disrupt all these fields and subfields within the banking world. And today we would be talking more about a practical and pragmatic aspects. What would be expected out of someone who is already in risk management and who want to disrupt the modeling world or quants world by honing up the skills of machine learning and data science, right? So initially, because there would be people coming from different background, I would be taking 10-15 minutes to just cover the overall maybe landscape or terrain, and then we will go into a Q&A kind of a session where Nitish would be acting as an interviewer, I would be role playing as an interviewee, and he would be just grilling me on aspects, practical aspects, just to simulate a scenario how a risk management interview would happen. We would not make it more complex and also not very generic, but we will keep it at a mid level of complexity for the understanding of all, so that you get a feeler, right, how such interviews will happen, right? So as you may see over here, right, on the left hand side, you could see that maybe this is the existing credit risk framework, which is already there in various banks, which is predominantly driven by the statistical models. And those statistical models are of the form of probability of default rating model, loss given default recovery model, exposure at default exposure models, right? So when we combine all these models along with few other parameters like correlation, concentration, we get to the expected loss or unexpected loss. Expected loss is used for the provisioning requirements of the bank, and unexpected loss is used for the capital requirements, be it the Basel minimum capital requirement or the stress capital requirement or economic capital requirement, which is ascertained by unexpected loss. Now, having said this, there are multiple other applications, obviously, of using these PD, LGD, EAD outputs. You could banks determine the risk appetite or risk tolerance or risk limits based on a combination of PD, LGD, EAD, a multiplication of PD, LGD, EAD. At certain expected loss, they or they determine what kind of risk appetite or risk limits they should set. Similarly, the pricing of the credits and the pricing of the credit instruments or a loan is also based on these parameters. So not only provisioning, not just regulatory capital, not only stress or economic capital, but pricing, risk appetite, risk limits, risk tolerance, risk strategy, portfolio selection, portfolio optimization, a lot of the aspects of modeling depends upon these three models. Now, having said that, now in the current context, how this landscape is changing, that's the question maybe. So this is a statistical model, and statistical models are generally characterized with very presumptive and very sticky assumptions, right? You would have linear logistic regression or probabilistic regression, logit probit forms, which generally have a lot of sticky assumptions about the underlying normality of the underlying data distribution, about maybe a lot of things, like there should be no multicollinearity within the data amongst the variables which you have chosen for the model. The errors should be independently and identically distributed. A lot of these sticky assumption doesn't restrict the modeling landscape to deal with data which is which is transformed a lot. Hence when you transform the data, it move away from reality, and you are also constrained uh, in using the data. So you could only use the data to the extent that it respect the and it doesn't violate the assumptions, underlying assumption of the model. That being said, the new way of doing modeling, machine learning modeling or data driven modeling, is completely assumption free modeling or theory free modeling. Now it what it takes is, it takes data, learn the patterns which we call pattern recognition, and after learning those particular patterns, what it exactly does is, it creates its own functional form or parameterization. It decides the parameters of the model, it decides which variable will go into the model, what kind of coefficients will be associated with those particular variables, what kind of functional form that particular model will take, and all these things without making any sticky assumptions. So that's the area. And generally, in recent times, what we have seen is that this particular area has been disrupted by uh, mostly the random forest, some kind of a tree based models, right? Like you used to have the classification and regression tree. Now it has been transformed into something called a a sort of a bagging technique, bagging algorithm, where you not only build one tree but multiple tree. So you call it random forest. Similarly, there's another technique called boosting method, where you build one model on top of another. That is another way of machine learning way of doing this. So these particular methods are heavily used in credit risk landscape, as well as the neural networks. You must have heard about neural networks somewhere, right? But the broader idea about neural networks is how our brain functions, and that kind of neuron or neuroscience has been encoded into an algorithm which is called neural networks, which is a layered network with multiple, each layer having multiple neurons, and each neuron doing some little thing on the data, right? And similarly, we would have multiple clustering algorithm, which we call like the principal component analysis. Now today we have multiple such uh, k nearest neighbor or clustering algorithm, which will cluster the data or do some associative association amongst the data, which are the closest neighbors to each other. What it means is, in order to segment the data, in order to cluster the data, in order to maybe do some segment modeling, right? We use clustering techniques which are which comes in new form under the machine learning. So this is the area which is mainly predominantly driven by the machine learning, and how it is disrupting the world of credit risk modeling. Now see, on the other side, we have this market risk modeling, and uh, the the counterparty credit risk modeling, that is also very heavily disrupted by machine learning algorithm. But majorly for that area, market risk modeling and counterparty credit risk modeling, which is derivative modeling, we have time series models, which we call sequential learning, time series model which we call sequential learning. And there we generally use neural network, deep neural networks, and different architectures and different designs of neural networks, different structures of neural networks, right? Which are discriminated by how many, not only by the nature of neural network, like whether it is a recurrent neural network, it is a multi-layer perceptron, what kind of neural network it is, but also by the architecture and design of the neural networks, how many layers you have in the neural networks, how many neurons you would have under each layer of the neural network. That is for the machine learning expert to decide. But basically there are two rather very broad areas which are emerging, where there has been a lot of research and experimentation under the market risk. So a lot of price forecasting algorithms, uh, uh, as well as volatility forecasting algorithms, right? Price forecasting, volatility forecasting, return forecasting problems, which are time series problems, which were previously handled by your uh, Gauge, Arch, Arima, Ceremax kind of statistical models, time series models, now have been taken care by neural networks, right? The idea here is that why neural networks? Because neural networks allow you to go in high dimension, use a lot of features, a lot of variables, rather than restricting to very few variables. And there's a problem with the data, that financial data is very noisy. And generally, when you deal with any time series data, you will understand that there are very very it has very time heterogeneous features. Like data would change, the distributional properties of the data would change in different, across once you go from one time snapshot to another time snapshot. And that is not well handled by the traditional time series forecasting methods like your Gauge, Arch, Arima, Ceremax, and all of that. And that's why maybe neural networks have been employed here to harness the potential of using a lot of variables, right? Creating a huge network of neurons or layers within that particular network to possibly take as many variables, as many features as possible, right? As well as also maybe dealing with the time heterogeneity of the data, right? So if data is not time homogeneous, the distributional properties are variant, across different times snapshot, then obviously neural network would handle it very very well, right? And another application in counterparty creditors, which is the area of derivative modeling, which has been in focus since the 2008 2010 Lehman Brother collapse or AIG collapse, and the learning from that, which has been taken forward in Basel 3 and Basel 4, is the area of derivative modeling, or derivative exposure modeling, or derivative CVA, credit valuation adjustments, market valuation adjustment, the margin valuation adjustment, collateral valuation adjustments, what we call the XVA. So the XVA regime, how we price the uh, derivative, how we determine the fair value, fair price of the derivative instrument, or for the counterparty credit risk, is an area where we do the risk neutral pricing, and the traditional way of doing it, right? How we used to price the instrument, maybe aggregate, do the aggregation, and then maybe derive some risk measures, has been replaced by neural network now, right? Again, that is also one of the area where we use a lot of Monte Carlo simulation. And in conjunction with the previous session where I told you why Monte Carlo has been on most of the numerical methods like Monte Carlo simulation or your finite difference method has been replaced by machine learning algorithm, right? A similar pattern here, that maybe the machine learning algorithm are heavily used for XVA modeling as well as exposure modeling when it comes to derivative risk, which we call the counterparty credit risk. So that's a brief of a brief context here. And you could see here that maybe when it comes to uh, different use cases of machine learning, now it's not the case that there are the sparse number of use cases, rather it is all pervasive across creditors, counterparty creditors, and market risk, and across different use cases to different businesses, like your retail modeling, your institutional modeling, your trading modeling, everything is getting disrupted, right? And there are multiple use cases which are where we are predicting asset prices, where we are predicting asset return, asset volatility, asset sensitivities, asset correlation, right? Asset covariance, right? We are predicting credit risk, probability of default, loss given default, exposure at default for different kind of portfolios. Sometimes it would be consumer portfolio, retail portfolio, corporate portfolio, commercial real estate portfolio, right? As well as we are using it a lot in the fraud analytics space, uh, and balance sheet forecasting space. So the cases are, from back office to front office, the cases are quite the use cases are quite uh, you know uh, have been tried out and now established. It's more about now, in the current context, the industry is more of experimenting with a few techniques which have already been established, to finally maybe seek the regulatory approval or seek the regulatory acceptance of those particular models, and start using them more and more, not only for in the regulatory context but non-regulatory context, like pricing, risk appetite, risk limits, risk strategy, portfolio selection, portfolio optimization, all these contexts, even your trading strategy, or maybe many of the specific trading strategy are now built based on the machine learning algorithm, as well as your stress testing, scenario analysis, and all of that. So there are a lot of use cases here, right? So that maybe, and mostly, as I covered, that for credit risk per se, right, the industry is mostly using the bagging and the boosting techniques. Bagging are basically the tree based models, like your random forest or decision tree or based models, and boosting is again, a different variant of that particular model. But in boosting, rather than parallelly building the trees, we build one on top of another, right? So we have boosting methods, we have bagging methods, but essentially they can be called as decision tree at scale, growing a particular tree, decision tree, a card tree, classification and regression tree at scale, right? So the, a lot of these are used in the credit risk space, and in the market risk and counterparty credit risk space, mostly the neural networks, different type of neural networks, deep neural networks. Sometimes it would be recurrent neural network, sometimes it would be different architecture of recurrent neural network, like your long short term memory or the gated recurrent unit. So these are different architecture of neural network. They are heavily used for doing the price forecasting problems, mostly time series problems, volatility forecasting problems, uh, index forecasting problems, commodity forecasting problems, interest rate forecasting problems, right, short rate forecasting problems, and all of different type of forecasting problems, as well as in order to evaluate the sensitivities, higher order sensitivities, not just limiting ourselves to first order sensitivity of the derivative of the price of the instrument to different market risk variables, but going beyond the first order sensitivity, like maybe going beyond that, talking about volga, you know gamma, uh, high level sensitivities would be modeled using the Monte Carlo methods. Not the Monte Carlo, but the deep DNN method, deep learning neural network methods. So that's where maybe the context setting goes, and maybe I'll now we will kick off with the sort of interview where I'm already nervous, as you can see, right? So so maybe over to you, Nitish, maybe to start maybe with this uh, yeah, interview.
So yes, as Sanjay mentioned, so I will be the interviewer, and Sanjay will be the role playing as an interviewee. So again, maybe we'll start the interview, and then just to mention again, this is like we would simulate like a mid-level position. So it's not like absolute basics position. I mean, entry-level position, and neither it is like a very senior level position. It's like we'll be simulating a mid-level position interview, right? So yeah, I mean, let's start with the interview process. So yeah, Sanjay, thanks for joining. So maybe we'll start by asking a question on like if you can share and elaborate on the machine learning, some of the machine learning use cases that are used for machine market risk forecasting problem sets.
Uh, Thanks, Nitish, and thanks for giving me this opportunity. And I'll start sharing the specific use cases which are maybe tried out and which are very much used or experimented within the market risk. And all of us know that the market risk has been now, the regulation has been now changed from the previous Basel regulation to the fundamental review of trading book implementation, right?
Right.
So which requires you to calculate the expected shortfall, which is the new risk measure, then replacing the old risk measure, which was the value at risk. So as the thing goes, when it comes to the market risk, we generally would like to we generally come across or encounter various forecasting problems, which are essentially the sequential learning problems, because when it comes to forecasting problems, they are time series. So when it comes to, say, forecasting of any risk measure, like forecasting var, value at risk, or maybe the expected shortfall in the current context, right? Or maybe forecasting a price. The price could be price of an index like S&P 500, or FTSE, DAX, CAC, or MSCI, emerging market index, or Shanghai stock market, stock exchange composite index, or KOSPI, which is a South Korean index. So either it would
Right.
be an index forecasting problem, index price forecasting problems, or index volatility forecasting problem, or loss forecasting problem, VAR, or expected shortfall forecasting problem. So all these forecasting problem are essentially, a sequential learning, right, in machine learning terms. And they are time series problems, because we are trying to model the future value, predict the future value, forecast the future value based on the lags uh, in the same variable, right? So hence, it will be better, one of the algorithm which is well equipped to handle such problems, and is generally proven to be very efficient, is the deep neural network, which is very good at pattern recognition. And generally, with these sequential learning problems, task, we have a pattern recognition, to do, right? And what do I mean by pattern recognition? Generally, you could see that maybe there are a lot of patterns in the data, and you have to take the time series data and examine, right, detect a right pattern and segregate that pattern from the noise of the data. The financial data is very noisy, so you have to segregate the signal from the noise, and these signals capture the patterns. And these patterns are sometimes, you could see there would be double top or bottom in, how
Right.
kind of pattern where the stock price would go. There would be triple top and bottom, there would be head and shoulders kind of pattern, there would be rounded top and bottom, there would be spike top and bottom. All these kind of are different examples of pattern. There would be triangular pattern, there would be diamond pattern, there would be a pin and pattern, there would be rectangle. So all these patterns, right, means something or the other for a trading strategy, right? Whether the price, at which we have taken the position, we need to do have an exit, we need to take an entry into the market, we need to have more conservative risk capital, all of that. And generally neural networks, and specifically the recurrent neural networks, and different architectures of recurrent neural network, like your long short term memory or gated recurrent unit are used. One of the inherent advantage of using recurrent neural network is, as we all know from the quant finance, that these time series problem generally are based on Markovian chains. The recurrent neural network is based on a methodology of Markov chain, right? Which is that maybe uh, which is a memoryless property of the price or any volatility, any risk metric, which says that it doesn't really matter where what the price was day before yesterday or day to day before yesterday. All it matters is what it was at the current time, or just the previous time, right? So the price carries all the signals when as it evolves, and the current price carries all the information which has been disseminated in the market. And now we could use that particular price certain lag the recent price, the latest price with certain lag to predict the future price. So that's the Markovian chain property, which is the underlying theory or basis of the recurrent neural network. And these sequential learning tasks can then be learned by using the deep neural network, and the architecture can be maybe decided upfront to solve these problems.
Yes, quite elaborate and well explained. Yeah, so since you mentioned about the deep neural network, so if you can actually now mention or call out about like advantages of deep learning or deep learning neural networks in specific.
Yeah. So thanks for asking this question. Maybe it naturally flows through. Maybe once we talk about use cases that we need. Basically for most of the market risk and counterparty credit risk use cases, specifically with respect to price volatility, index forecasting, asset class forecasting, right, as well as the exposure modeling or the valuation adjustment area in the counterparty credit risk, we use deep neural network. And we want to basically generally the idea is to exploit certain advantages which are very clear advantages over and above the typical Monte Carlo simulation method, or the time series modeling, the traditional statistical time series modeling, how we used to handle these kind of problem sets, right? So one of the advantage of neural network is it generalize very well. What do we mean by generalization or regularization ability of the neural network? That once it learns, once it learns a function, right, you can change the data. You can deploy that neural network algorithm on any data set, or entirely different data set, or a change in the existing data set. It should ideally produce the same kind of output. So it generalizes very well,
Right.
right? It regularized very well. It's generalized, it's learning from the data, huge amount of data. The This call out for another disadvantage here as well, that it need to then trained on huge data. So you need to have a mass of data to train a neural network, but once it is trained, then it is very well generalizable and regularizable. So that's one of the key advantage of neural network, and that's what we need when it comes to these market risk and counterparty credit risk problem. We don't have the lack of data, right? Because we could get all the price data from Thomson Reuters, Bloomberg, or volatility data from S&P 500, or different. This is a market data, right, which we could get. The problem is that generally the traditional method, they don't journalize well, right, which is the advantage which DNN brings here. The second part is the robustness and stability. So once the neural network has been trained, its parameters are robust and stable. It won't change that much, right? But during training, you need to do a lot of experimentation to and a lot of different try out a lot of different architecture of the same neural network by using different layers, different neurons within different layers, right, to make sure that everything, every possibility has been exploited. But once you settle down on one particular architecture of the neural network, which is finally used to do your prediction or forecasting problem, right, it is not expected, the parameters or the coefficients of the model are not expected to change that much, right? The Another advantage of neural network is it very well map the input output. So what we mean by that is, so whatever your inputs is in your model, some of the uh, you know uh, 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 intrinsic factors or extraneous factors, like inflation or housing price index, or maybe wholesale price index, or maybe interest rates, whatever your inputs is, it it maps out those inputs to your output. What is the final forecasted price, and to what extent each of the input will play a role in the final forecasted price. So it does that very task very efficiently.
Right.
Obviously that goes with every machine learning algorithm, that it doesn't assume any underlying distributional properties, and it is very theory free and very much hypothesis free and assumption free way of doing modeling. It is purely data driven way of doing modeling. And the last but not the least, the neural networks are very flexible, right? They are very scalable. So tomorrow if you decide to not only take say 20s or 30s of variables, but just want to exploit 100 variables in your model, right? You could flexibly scale the same neural network which you build, right, by having more layers, more neurons each layer, and do that. So the essentially their architecture is very flexible and scalable. That's again one of the advantage, which is unlike the traditional methods. If you change the if you change the variables or features which goes into your model, you have to redo your modeling from scratch, right? But here you could reuse or the existing architecture and just enhance its architecture a bit, expand its architecture a bit to cover a huge feature space. So that's one very very good advantage of neural networks over and above the traditional methods.
Wonderful. So, yeah, good explanation again. Thanks for that. So, I mean, now, like, since we have heard about the advantages of deep learning algorithms, right? So, and since also you mentioned about, of course, you talked briefly about one of the disadvantages that it requires a very large data set to train. So, I mean, would you like to elaborate some more on the disadvantages of deep learning, particularly the deep neural networks?
Yeah. So that's one of the area which poses a challenge, and mostly a regulatory challenge and bottleneck. That deep learning neural networks are mostly conceived as very black boxes. What we mean by black boxes, you only know the architecture, but if you were to explain it to someone, like what went where, right? Which particular layer extracted which feature, right? And what kind of importance it has assigned to that particular feature, it is very black box as on today, right? Although this is an area of research where there are many research going on to make, which is under the name of explainable AI, right? Where a lot of techniques are coming to explain the outputs of the neural networks or deep neural networks, right? But this is still an area which the regulator, the model validators, the model auditor, right, and many other stakeholders who would be using it for some real purposes would be very very skeptical about, right? the
Right.
other the other aspect which is a bit daunting is that neural network tend to overfit. The problem with overfitting is that uh, it does too much with the data, right? It plays too much with the data, and somehow in the process it mugs up the data, right? So mugging up the data means that although it will give very super accurate results, but you would not be sure that whether those results are true pattern or it has literally mug up that particular data, right? So that problem is called the overfitting problem, where it over predicts on the data where it is trained, where that neural network is estimated out of or trained, the estimation or development data. uh, and hence you need to try that neural network before using it for any real life purposes. You need to try that neural network not just on the data on which it is trained, but rather the data which it has never seen, to overcome that overfitting problem, so that you will clearly examine that if tomorrow the data will change, the data behavior will change, the model should not behave very weirdly, right? So that's overfitting problem, which maybe obviously which is obviously the case with any complex model, not just neural network or machine learning. Even in traditional paradigm, if you would have built a very complex model like polynomial regression or some kind of thing, right, they would have again same problem, right? They would be characterized with overfitting, right? They would mug up the data rather than only learning the key patterns. They would mug up the data, right? So the next thing is that it requires a lot of expertise, and expertise means that somebody need to learn the methodology very well, right? To do the experimentation, what kind of architectural design a network should take, right? What how the hyper parameters of the neural network, like the number of layers in the neural network or number of neurons spread within each layer of the neural network, right? The transformation function from one layer to another, right? What kind of transformation function you will use. All these things will come with a lot of practice and conceptual insights, right? And a lot of experimentation. Nobody knows yet the answer, so the industry is experimenting, but somebody need to be you know learning these things to become a neural network expert, right? And again, maybe it requires a lot of training time, and the time of convergence to the real solution is also very high. So it doesn't just simply, it can't simply be trained on the cpu of your computer. It requires the multi-core capability, the multi-threading capability, or the parallel computing capability of your hardware, as well as a lot of gpus to train. You can't simply train on one CPU, but you rather require a lot of you know very powerful hardware, right? Processing power to train the neural networks, right? Because it involves a lot many parameters than a general uh, traditional method, right? So those parameters require a lot of training, and a lot of training time need to be backed up with a lot of computational power, right? So those are basically few of the demerits or misgivings or maybe bottlenecks of the neural network.
That is, yeah, absolutely, absolutely. So, like going to the next question, actually. Um, Next, what I would like to ask is, I mean, if you can cover a use case of RNN, that is recurrent neural network LSTM architecture, to solve a sequential learning task. I mean,
Yeah.
any use case example that you can give.
So that's one of the area where a lot of adoption is happening, and thanks for asking this question maybe. And so sequential learning tasks are basically time series problem. So it is just a new word for a old adage, right? Generally for time series problem, as you know, that sequentially the data is sequential in nature. It is with timestamps, right? So we use a different kind of neural network, which is called recurrent neural network, which is based on these Markov chain, right? Markovian property, right? And these Markov chain property, sorry, these Markov chain property, you know, is is uh, y- is the basis of hidden Markov chain, is the basis of this, right? So when you have this hidden Markov chain, right, you you assume that maybe how your price behavior, how your volatility behavior, how your index behavior pans out through the historical time series. It doesn't really matter where it coming from, where it's coming from. It all it matters is where it has reached the current state, right? So Markovian property or hidden Markov chains assume that maybe as the data emerges through time, right? It keep capturing the structural dynamics of the data, right? So there's no asymmetry in it, and we need not to go back a year back, what was the price a year back, right? We just need to take the latest price data, or the latest maybe position data, and the latest volatility data, and latest sensitivity data, latest return data, right? To understand the to forecast and understand the behavior of the future, which direction it is going, right? So generally, I'm going to discuss a use case which is related to the volatility forecasting, right? And the volatility forecasting of the data which I used, while working on this use case, was the VIX data. And as you know, VIX is an index, volatility index, as it is called, is a volatility of S&P 500 index, right? So it is a well renowned index. The price data is available even on open sources like Yahoo Finance, right? Or maybe different APIs could be used, application interfaces could be used to bring in the historical time series of VIX prices or the VIX price data. So I brought that in for all the trading days, like 250 trading days of the year, right? I additionally included what was the open, high, low close, adjusted close, and volume, these additional features, right? uh, and there then the first thing first, in order to do the exploratory data analysis on the this particular time series of fixed prices, right, which is the volatility index prices, right? What we exactly did is we did a seasonal decomposition. We decomposed the price behavior into seasonality. What was the seasonality of that data, whether there was any clustering volatility, because volatility exhibit the clustering trend as well, which means that a higher spike in the volatilities would be accompanied by another spike, another spike, another spike, another spike. So these are clustering behavior. A fall in the volatility will be accompanied, most likely be accompanied by more fall, more fall, more fall, more stable market, right? So this is the clustering behavior which we also extracted, right? And then we basically did some correlation plotting and some auto correlation plots and partial auto correlation plots. And finally we perform few tests and prepare the data, right? And uh, we use basically a neural network which is very well known uh, for capturing the short term and long term behavior of the series, which is called long short term memory, LSTM. And we use this particular network, and in order to compare and benchmark this network, this DNN network, we also use a gated recurrent network, which is again based on the Markovian chain property, and a hybrid network where we use some part of LSTM and some part of the gated recurrent neural network to build a hybrid network. And we then maybe trained all the hyperparameters, right? And eventually we were able to do for multiple experiments with on the real time, which decided which let us get comfortable with what would be the design and architecture of that particular neural network, and how basically different uh, based on what kind of accuracy we are seeing, what kind of design and architecture features or characteristic of the neural network we should adopt. So learning the neural network hyperparameters was one of the subtasks while doing this. And then we fitted this neural network on the VIX data, the S&P 500 volatility index data, to finally evaluate its performance with respect to traditional methods like GAR charts, ARIMA, Ceremax, as well as with respect to other machine learning alternative architectures like LSTM was compared, long short-term memory, which is one of the architecture, as I told you, of DNN, was compared with the gated recurrent unit, as well as a hybrid network. That okay, what if we could combine two different architecture into one and call it hybrid, and let's compare its performance with respect to the standalone performance of the long short-term memory DNN and gated recurrent unit DNN. And then we eventually concluded that the gated recurrent unit was better, right, due to some inherent advantages, right? And obviously we then use that, right? But the LSTM was more stable, so it was then a question of debate whether we want a stable performance in price forecasting or a more accurate performance in price forecasting. But the LSTM and GRU were came out to be the winners out of this particular exercise. And we then eventually solved this problem of volatility forecasting, which is one of the key problems for devising the volatility based strategies. The which is the volatility also goes as an input into many calculation, which will calculate your risk weighted assets and the capital number, right? The volatility is also used to determine your risk appetite and market risk trading limits, right? So it has a multiple uses. So use case caters to multiple applications on the front end and the back end side of the front office and back office, for risk management purposes. And this is how we have achieved the final results.
Wow, that was again a very exhaustive answer, quite well explained. So, I mean, so for today's round of interview, again, this is all I have to ask. I mean, the team will take it up with you for the next round. And the meantime, so we would conclude the role play with this. Now we would go into the Q&A session where we would actually take up questions. But before we go into the Q&A, I mean, just to give Sanjay a little breather, and also maybe to briefly speak about, like, again, the things that we are doing again in this machine learning and other areas, right? So which can actually help people who are interested in, like, making a career in this field. So to start with, all of you might already know by now, I mean, I represent Indian Institute of Quantitative Finance, and I mean, we are a body which specialize in education and training in the field of quant, financial engineering, risk management, algorithmic trading, and AI and machine learning, all advanced analytical areas of finance. And again, we're the oldest quant body in India, and have been trainers to major banks and financial institutions as well, and participants over the last almost 15 years now. Like, we have been the cheerleaders and like the front runners in promoting quant education in India, and many students or professionals have actually gone on to do our course and like have made successful careers in quant and risk and algo trading, machine learning and related areas, right? So I mean, in case anybody is interested in like making a career in advanced analytical areas of finance, particularly in today's context, if somebody is interested in learning about machine learning aspects of finance, so we have a very specific course which prepares you by teaching machine learning and data science in context of in finance, a very comprehensive course which teaches in deep all machine learning related concepts in like supervised, unsupervised, NLP, deep learning, and all these aspects. And particularly, this is like a course which the highlight is that here all the use cases, all the white papers, all the analysis, everything is taught in context of finance. I mean, the applications are in fintech, credit modeling, derivative valuation and pricing, risk management, algorithmic trading. So all application areas in this course is taught in context of uh, finance. And in case I mean, anybody wants to make a career in machine learning, particularly in finance, this is like a course to look at. We have other courses in other advanced analytical areas in quantitative finance and risk management, financial engineering. These are courses for people who want to make careers in international banks, particularly to work in the quant or the risk management or quant trading teams, right? So then again, if somebody wants to build a quant domain knowledge, either of these courses can be looked at. And if somebody is specifically interested in learning about algorithmic trading, then we have specific courses in algorithmic trading as well. 8 months course, postgraduate program in algorithmic trading, where we cover all aspects of algorithmic trading end to end, using different kinds of strategies, technical analysis based strategies, machine learning based strategies, and quant model based strategies. And then we have a shorter course for people who want to learn algorithmic trading without going into the too much into the quant side. So basically a course which teaches end-to-end all aspects of algorithmic trading using technical analysis. So what I would like to highlight is, I mean, our courses, we not only teach uh, the theory plus the practical modeling, but again, these are courses where we do help with the career track as well, and then the placement is definitely highlight of all these courses, right? So I mean, since today's session is more on the machine learning topic, so I mean, in terms of the CPMLF course, certificate program in machine learning for finance course, the career track that actually, I mean, I would like to discuss on that actually a little bit. right? So what are the potential career avenues that are available in the industry for aspirants of the this machine learning program? The machine learning program caters to building practitioner level skills to broadly cater to any and all of ML and data science driven loan families, with a few real examples from the job market as given below, right? So when you can go on to become a data scientist for financial accounting and decision systems, you can go into machine learning model designing positions for financial forecasting and predictive models. You can go into forensic audit data science, and you can become a data scientist in forensic audit. You can go into fraud analytics and become a machine learning expert in fraud analytics. You can go into risk, finance, compliance, machine learning, data engineer in those disciplines. And you can become a machine learning modeler for quantitative finance models. You can go into machine learning driven algorithmic and become ML driven algorithmic trader. You can go into machine learning model validation and become an expert there, right? So I mean, these are few teams, and I mean, in terms of the support that we provide, so it starts absolute from not only during the course but even before the course starts, right? So even before you take admission, we start by doing your career counseling. I mean, we evaluate your background, and then we suggest what should be the career track that you should be taking up. I mean, we guide you on what kind of career path you should be following. We do a deep counseling, and I mean, and then of course we suggest also, like, again, this is your profile, what would be the right course, and again, to actually, I mean, to make a dash into the industry. And if you're already working in, what kind of future path you should be taking, right? So I mean, we have a pool of industry experts who give you career mentorship as well. We have a dedicated placement support team which works with you at, I mean, when you do complete a course, those who successfully complete the course, the support team, placement support team particularly, works with you, do your individual profiling, and then basis your profile, they will then take your resume and connect you to the right teams depending on which course you do. I mean, if it is like a machine learning course, I mean, for companies which are into machine learning, be it the international banks or trading desk, hedge funds, or the other financial institutions, analytical companies, now even the fintech organizations. If you're doing a quant course, then of course they will be targeting relevant roles in the quant and the risk analytics teams of all these international banks, big four consulting firms, and other analytical courses as well. I mean, teams, right? And the industry association, we have a very strong network of industry association. Being the oldest quant body in India, we all being from the quant industry and the advanced analytical industry in finance, right? So the industry connect is pretty strong, with like more than 2 decades of experience in this field, in education, in like analytics, in the product development, in the quant domain. So the industry connect is pretty strong, right? And then other than that, we have a dedicated support team connecting with the industry on a regular basis, and like particularly the recruitment teams, right? And then the faculties, as you see, I mean, Sanjay is one of them. There's a huge faculty list where like people like Sanjay and others who are domain experts, leaders from the industry, that they come and teach for us. So we have a strong network of like faculty as well. Then a lot of the alumni over the last 1.5 decades, they have actually, I mean, of course, a lot of them are in very senior leading positions themselves, right? So overall, the industry association and connect is pretty strong. And I mean, we moreover help with your resume building, profile improvement. So it's like an end-to-end support on the placement side. I mean, because it's like, of course, I mean, learning is very important, and our courses are deep. They actually prepares you and makes you ready to directly plug in into any quant, risk analytics, machine learning related jobs post, if you can finish the course properly and done the course successfully, right? But I mean, but again, and then of course, I mean, it is I mean, we also take a lot of uh, effort in like helping you in utilizing all this knowledge and connecting you to the right teams, right? So I mean, yes, and as I was mentioning, it's been a long journey, 1.5 decades working in the quant education field. I mean, we are the pioneers in quant education in India, and I mean, lot of participants both from the industry and like again even students have gone on to do our course, and they have joined the industry with basis this course. They have, if they're already working, they have used this courses to further go on to more deeper improved profiles in this industry, right? So I mean, there have been many students who have passed out some of them definitely have shared their thoughts as well. Abhijit being one of them. I mean, he's already he's a quant. I mean, and has done as one of our program in quantity finance and risk management. So essentially, then there are people like Rohan, uh, Karthik, uh, Yatish. I mean, these are just like a few examples. I mean, if somebody wants to see how people have done our courses and utilize them to improve their uh, and enter into the industry, particularly in the advanced quant analytics and risk management and machine learning related fields, right? So I mean, you can go to our testimonial page as well, not like for anything, but again to see like how people utilize our courses actually to in this and make an like further career dash, right? So, I mean, target companies of all these courses are hedge funds, investment banks, commercial banks, stock exchanges, consulting firms, IT companies, and what is not added here is like the new age fintech organizations as well. I mean, particularly from the machine learning course. So essentially, we have connects and we would help you, right? Um, yeah, I mean, it has been a long journey, and as I said, we have worked very closely with the industry. I mean, these are just like a small list of people we have worked with. The list is pretty exhaustive. Just to mention a few of them, where we have been consultant and trainers and like other associations. I mean, some of them like a lot of them are recruits from us as well, right? So I mean, this is just a small list of like people we have worked with, right? And yes, I mean, in our overall endeavor to promote this quant and machine learning and all this field in finance, I mean, we work regularly with leading educational bodies as well, IIT Bombay, BITS, Pilani, NITIs, to name a few, right? So where we work with to encourage the student community to understand this field and then again to join this particular industry, right? So anybody interested in like knowing more about us, I mean, you can our website at iiqf.org. You can call us on the number mentioned 8976993622. You can email us at info@iiqf.org. Right. So with that, we will now go into the Q&A. I mean, we'll take up the questions one by one. So Sanjay, if you are ready, so maybe like again, I'll start collating the questions for you.
Yep, sure.
All right. So the first question is from Ayush, and I mean, I'm not sure whether we can actually take up the entire question, but like again, maybe we can give him some guidance. So it's like it's not a question. He can actually, it's like more of explanation he wants. I mean, can you please explain the topic PCA and eigenvector? And he wants us to also explain how to find eigenvector in Excel. So I'm not sure, I mean, whether we would have enough time to show Excel calculation here, but again, if you can like briefly explain this to him.
Yeah. Yeah. So PCA, principal component analysis, is one of the clustering, way techniques where we use, the principal component analysis, and we use a lot of eigenvalues and eigenvectors there to decompose the feature space, huge feature space, into principal components. And uh, I would rather advise that maybe somebody who want to maybe do more of PCA or ICA or these techniques or KNN, K nearest neighbor, these techniques, they should use rather the potent libraries and modules from the Python, right? Because not only just you get the PC extracted, but also you get a visual effect as well, where you would be able to get a real feel about what each PCA is composed of, right? So that kind of thing, and we generally under one of the our module on clustering techniques, we explain PCA quite well, as well as draw a parallel with the machine learning algorithm, where we have multiple machine learning algorithms to do the same thing, right? To do the clustering and associative modeling, right, within the data set, right? And with respect to your question on eigenvalues and eigenvectors, maybe what I would say is that essentially, I don't know whether but you must be knowing already that these the basic idea here is for everyone that we generally look into the feature space or the vector space, right? And we extracted, a representation of multiple features by combining them into a principal component, and that we use by using the eigenvalues and eigenvectors. So if you have a huge feature space like hundreds and thousands of features, right, you could not use all those features into your model, because then the model will become a high dimensional model and very complex model, and it will pose a problem, right? You then use the PCA's principal components of those models, uh, as well as in those circumstances where the PCA is used using the eigenvalues and eigenvectors, is that where there's a general problem of multicollinearity. If your data set, even if you don't have high number of features or variables, but your data set is highly multicollinear, the variables are highly multicollinear, but going back to some of the SME industry experts, you hear back from them, no, we they want to include most of them, right? Like in credit risk problems, when you talk about different leverage ratios, how different leverage ratios are calculated, debt serviceability ratio with different numerators and denominators, sometimes you pose a challenge that a credit officer or a rating expert would say, no, 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 I don't drop anyone, I still want all of them in my model. Now what to do with that, right? You take all those different ways of calculating your debt serviceability or the leverage ratios, and you draw, you using the eigen values and eigenvectors and the PCA techniques, you create a principal components which will be a composite representation of all of them into one, and then use it as a single feature in your, or single variable in your model. So that's where how it is. But with respect to Excel, maybe I think it won't be possible here, but obviously we would be teaching the Python implementation, as well as whenever somebody would definitely would like to know how to calculate it in Excel, we would maybe touch upon that particular topic there, because it is quite exhaustive, and we need to play with data to make you understand maybe how to go about calculating the PCS.
Yes, I hope that answers your question, Ayush. And if you have any follow-up question, you can put up in the chat window. Anyway, currently going to the next question. Actually, it is from Neelam, and mentions that I have total 7 years of IT experience, out of which 2.5 years is in financial services domain using legacy applications. After that, I took a voluntary break of 5 years, but in those 5 years, I have done multiple certifications and self-learning courses in Python, ML, data science area, also a past level 2 of CFA. So now how should I get back into industry smoothly with my new skill set? How does this industry specifically considers gap candidates? Yeah, I mean, that's maybe a very relevant question for a lot of people, particularly those who has gaps in their career. So, I mean, yeah, I mean, if you can give your thoughts on that, or share your thoughts on that.
Okay, so I today the industry frankly is moving in a freelancing kind of a mode, because the skill set in itself has become uh, so niche, specifically the machine learning and data science skill sets. The industry has a dearth of candidates, so I don't see that as a huge bottleneck. And with the fintech companies evolving and many challenger banks evolving, they don't really care what is your experience and gaps, and as long as you have a skill and you have a Git repository of projects which you can showcase to them that this is the kind of model I have built, and these are the techniques which I have I'm SME upon, right? So, and I have a full throttle understanding of how the application use cases. I don't see maybe the pattern. Everyone noticed that maybe the pattern now in next 2 to 3 years will change for hiring in these specialized skills. It will not be based on certain JDs. Rather, it would be asking you to share your Git repository account, where you would have to showcase that okay, these are the models you have built, and you would be evaluated on those, as well as there are multiple hackathons which we also, while designing this course, take notice of. And we while somebody take this course and is we promote them and prepare them for different hackathons, right? And the hack ranks from those hackathons are taken very seriously by the industry, right? So the skill set is not in the evaluated in the legacy way at all. So nobody would ask, right, how many years you spend in the job, or maybe how many years you spend in a specific role, where you are coming from. Even the data scientists from other areas like astrophysics, cosmology, other areas are jumping in and joining the financial industry. Even for you know biotech or pharmaceutical, if a data scientist is working there, he could easily be. So one of the very important thing about machine learning and data science skills is it's fungible, right? It has a huge fungibility, so it doesn't restrict you to a particular domain. If you are a seasoned machine learning expert or data scientist, you could move and switch industries, sectors, roles, right? Domains, and it would remain fungible. Tomorrow you would be hired by Google or Amazon, because they are also applying for getting into the financial services. So they are sitting on a lot of lobby list power to get the license soon, and maybe tomorrow they would be the new financial institution of the 21st century. So be prepared. Maybe just I don't see the forthcoming era to be uh, having very stereotypical hiring pattern.
Yeah, absolutely. That is very well answered. And I mean, in fact, coming from you, who is like a regular recruiter in the machine learning field in finance, so I hope that answers your question, right? So again, any follow up on that, please feel free to type in on the chat window, Nilam. But for the timing, going to the next question. Next question is from Amol, and he asks, with regard to pursuing CPMLF, that is our certificate program in machine learning for finance, what is the expected level of proficiency required in data structures and algorithms?
I would say none. Right? Right. So it's a ground zero, so you need to have intent. I only expect somebody, some aspirant. So I don't want people to join by blindly. They need to have a vision for themselves. They need to have conviction, because some of these things would require mathematical, statistical, probability, programming skills. And we have module 0, which is quite exhaustive and very comprehensive to cover all these aspects, even before we formally start the machine learning modules, right? So you will be going into learning the basics of mathematics, which will underpin the machine learning techniques, and uh, probability statistics, and as well as programming from scratch. You will be understanding the data structure and the data scientist's way of looking at the data structure, not just data analyst way of looking at data sets, but data scientist way of looking at data sets. So that will change your perspective how data scientists look at it, how they story tell, right, from the data, and what kind of patterns they see in the data, and what are the techniques to they use to capture the key patterns in the data, which forms the driving force for deciding the machine learning technique of particular data set. And the other part is that generally people have and obviously it's not something very exceptional for somebody who doesn't know this thing, because this is a new thing, right, for everyone, even for very very seasoned professionals who have been working in quantitative finance and financial engineering and computational finance, front office models or back office models. They are also grappling with the same challenge. So the winning strategy here is to get on quickly and to turn it around for you, and to believe that you would be able to do it, and to have some conviction that you would be able to devote some time to it, which is required, which I never discount. That somebody should not assume that it would be a cakewalk. It would be a kind of a very bumpy journey, because obviously you have to, after you being student long back, and you have to again revive yourself to. But we will be there, we will be there to mentor you, we will be there to provide books, guidance, literature papers, Python codes, right? The Python lab support, maybe the practice sessions, all of that will be provided. The ecosystem, you leave it to us, right? And the only thing is that conviction and positive outlook. Yeah, that's all I can say. Yeah.
Yes, yeah, absolutely. So I hope that answers your question. Again, you for if you want to ask anything, you can ask a follow-up question. But moving on to the next question, which is from Atul, and he says that I don't have experience in modeling and or risk. My profile is somewhat related with credit underwriting, earlier in software development, also done data science. I have 20 years of experience in other fields. Can I get a chance to work in this domain? What are the entry barriers? How is the salaries in this domain?
So Atul, if you go through my LinkedIn profile, I have been a credit underwriter, right? So right, for quite almost half of my career, and for 16 years, if my career has clocked 16 years, so it's been like for good 7 years I was credit underwriter. So to answer your question, obviously domain cannot be discounted. Be it any role, be it any new age machine learning role, domain cannot be discounted. You already have domain expertise, right? You need to start somewhere, pivoting yourself in a different direction, where now domain is just not uh, you know uh, it's a world of techno functional, right, skills. And the techno part of it, for somebody who already is a domain expert coming from a credit risk domain or credit underwriting domain or a rating analyst domain, right, is to pivot himself in the modeling world. And the modeling world also, the disruptive, how it is being already disrupted, right? So the existing modelers, those who are using statistical modeling, have been disrupted. They are themselves getting on these courses. I would not just our course, but multiple courses, they are also getting on these courses and learning these skills. So they are not different from you, right? This thing again is new to you, new to them, right? So I don't think that you have a disadvantage there, but it might take a year and a half of journey to get you there, right?
Yeah, absolutely. I mean, absolutely. So, the recurring theme here is like Vikas and all others, right? So, I mean, unlike a lot of other fields, machine learning and data science, I mean, these are evolving fields, right? So, I mean, there is scope for a lot of people from different other backgrounds to enter into this field if you acquire the right skill sets. Because again, I mean, being like a new sunshine kind of industry, I mean, also, of course, machine learning and data science has been in existence for many, many years. It's not like this has happened in last 5 years, but like last half a decade or so, it has exploded, right? So there's a huge requirement, and I mean, and no, the trained people is not like that much, because again, they I mean, I mean, machine learning was not like a huge set of profiles earlier, right? So a lot of people actually, I mean, that is the reason. I mean, it's an advantage as well. So essentially, there are not like a lot of people who are like having many years of experience in this field. So companies actually, I mean, they are looking for people actually having domain expertise, right? So if you acquire the skill sets, there is like a scope to enter into this industry. I mean, from whatever other areas of work you have been, if you build your skill sets, you can get a chance. But as Sanjay rightly mentioned, to acquire the right skill sets, again, you have to allow yourself certain amount of time, right, to acquire the right skill sets. All right. So now going to the next question is from Adil. So Adil has explained, I mean, sorry, the question is that how much important it is to have expertise in econometrics along with stats, maths, or becoming data analysts or data scientists.
That's a thing of domain, Adil. So I would rather say that if you are into ERM kind of economic risk modeling kind of or enterprise risk modeling kind of very specialized domain, right? Obviously, econometrics would be required, but the other thing is that anyway we would be discussing use cases from each of these risk typologies. We would not be confining ourselves to credit risk or counterparty credit risk or market risk. We would have some stress testing or scenario analysis use cases where we would use the macroeconomic variables, to predict, just like inflation or interest rates, or maybe any broader macro economic variable, right? So you could learn parallelly as well, if but generally these domain skills are very mixed up. So slight risk management, slight econometrics skills, slight understanding of the regulation, right, would corroborate for a domain expert, right? So you need not to be very expert in anything, but you would be then seen as a data scientist and machine learning. That is going to be a primary core skill, right? Right. So the use cases will be differing, the use cases will change a lot. And today, in today's world, what I have seen is that these machine learning data scientist team is a core group, right? They don't they need to be generally understanding about the financial use cases, but they are not typified by one particular, you know very specific domain. They are not confined to that. They sit centrally within the organization, and they pick up use cases from different directions, right? So it's not that so your domain skill after doing machine learning or data science would be data science or machine learning, which is the primary domain skill on which you will be evaluated. Obviously then your understanding of certain application areas, that's it.
Yeah, absolutely. So, I mean, two questions. I mean, essentially, one, I mean, I'll combining this actually. So, uh, Atul has, like, again, he also additionally mentions that he has an FRM holder. So, I mean, Atul, if you remember his question, he's trying to come back. I mean, he has 20 years of experience in like different field and credit underwriting on which you explained, and what are the entry barriers, and he was asking about salaries in this domain. So he also mentioned additionally that he has an FRM, and also a question from Vikas that I'm an FRM, and like again I work in the markets, but I want to enter into overall the risk management industry, right? So I mean, how machine learning skills can help me in entering into the risk management industry?
So all these CFAs and FRMs and PRMs and CPAs and these certifications, they are renowned and well acknowledged certifications, right? They basically puts more meat to the flesh when you want to prove that you are a domain expert, right? But when you want to try into modeling world, you need a very different skill set, specifically the modeling and quants and the numerate field. So most of the JD job description, if you have come across, say that you must be from a numerate field. What does that mean is that you either should know the machine learning, which is a very unique advantage because not many people know it in the market. People know statistical way of doing it, people know the numerical way of doing it, but machine learning is they are themselves learning, right? So now like for like, if somebody would be a machine learning expert, he would be taken more seriously than some of these old models which are any which way challenged by the machine learning models, right? So that's what the point I wanted to make. Maybe a new entry into any new area or field, be it risk management or derivative pricing or derivative valuation or whatever it may be, algorithmic trading, would require you to hone up a new skill, right, which is already disrupting that particular field, right? As the field will be disrupted more by machine learning data science, the demand will increase. The upsurge in demand would not match the supply, because I we have always been facing this challenge that there are not many people in the market who are machine learning or data science expert. And you could see many BCG or McKinsey predictions that this would be the most so to say sexiest job of 21st century, right? So there's no doubt about it that it is very pervasive, and it is again, the added advantage is that it is domain agnostic, right? It is domain agnostic. Just bear that in mind. Once somebody champion this skill, right? He bastion every industry, right? He doesn't only bastion just the financial industry or a specific domain risk management within that. He bastion every industry, right? So that's the way forward.
Yes, absolutely. So I hope that answers your question, right? So going to the next question is from D. Pradeep, and he says that he works in a public sector. He's a public sector banker working as a manager scale 2, having experience of 10 plus years in banking. Want to change my field to specialized. Can you suggest how there are these courses will and which to choose? Currently having a package of about 14 lakhs per annum.
Hi Pradeep. Again, you must have noticed from my CV or my LinkedIn profile that I started with a PSU bank. Right? So quite a parallels with all of you, right? My journey was no different, right? And there are successes, there are failures, but the persistence is the key, right? Right. And so it doesn't really matter. The PSU banks now, I recently saw that even Axis Bank, many of the Indian private sector banks are also hiring data scientists and machine learning experts, right? So it's no different from the foreign banks, right? The trend is also catching up across Indian banks. And when generally I was working with consulting, we used to pitch more to Indian banks through various RFPs for these machine learning data science projects than to foreign banks, right? Right, sometimes you it's hard to make a big elephant dance, right? So right. So the thing is that maybe somebody looking to disrupt, again I'm going back to the reiterating the same point, should pick up a disruptive skill, right? Right. So there are multiple advantages. Not only this, but there are a lot of requirements in the industry where people with the machine learning skills are required as trainers, right? People with machine learning skills are required in consulting. Even if you won't get to the entire full throttle machine learning, but these skills are useful in consulting. If you pick up a consulting job, or if you pick up a full a sort of a advisory job, or if you do a freelancing, or if you do a trainer job, right? Because what is the buzz about? The buzz about is all about data science and machine learning in every walk of field. That's maybe my generic answer to this question. Like, that's how it is growing in its importance exponentially. Yeah.
Yeah, absolutely. And just to add to it, Pradeep, since you have asked about like which course to choose, of course, machine learning, uh, machine learning is definitely like the area to be. But again, if you want to stick to banking, particularly since you have a banking exposure, right? So another course also you may like to explore. It's called a certificate program in quantitative finance and risk management, which is also a course which is officially recommended by a lot of even government banks for their risk and treasury team. So if you have an interest in moving into risk and treasury and all this kind of departments, you can look at the certificate program in quantitative finance and risk management course as well, very specific to your banking domain, particularly for treasury and risk related jobs. So I mean, we can discuss more on that one-on-one, but I mean, machine learning is of course the way to go, given, I mean, and this is something I recommend to every professional whom I talk to, like a student who is trying to invest in industry. I mean, machine learning will definitely become all pervasive, right? In every industry, I mean, it's already, we are seeing that in every industry, machine learning is being used. So as we go further, I mean, it will become even more and more pervasive. So yes, learning machine learning will always be useful, whatever industry you work in going forward. Whether it is directly or indirectly used in your profile, that's like a separate thing. Whether, I mean, whether you directly want to move into machine learning related areas or not, that's also a separate thing. But knowing about it will always be helpful. But specific to your case, I mean, you may also look at a course called Certificate Program in Quantitative Finance and Risk Management in case you want to stick to your banking and you want to move into treasury and banks, right? Now, couple of more questions from Amol. One is like what Sanjay, I would request you to answer, and the second question I would answer. So first question from Amol is the scope of CPMLF for me, I am from software testing background.
So, Amol, I don't know whether you know it or not. Generally, in the market, most of the IT professionals and mid-career IT professionals are taking up machine learning course because they have got this team. Because this particular machine learning and data science skills require a lot of full stack development, right? Not just knowing how to write a code in your Python or any analytics language like Python, R, Julia, maybe Perl, but also to do how to do deployment, how to integrate your maybe algorithm to the backend, which will have big data technologies like Scala, Spark, Hive, and even testing role. Now, testing role in today's world in banks, investment banks specifically, are not called just testers. They are called just maybe they are named differently. They are called maybe the BDD developers, right? Behavioral driven development or developers, and the BDD, TDD, the test driven development and behavioral driven development means that even the requirements are written in the form of test scripts, right? Even the requirements are written in the form of test script. So if you give a requirement to somebody who is a developer, right, IT developer, right, you would write the test scenarios, test cases, test suits, right, first, and you give it to them, and they will code it accordingly so that the code will in itself be self testing, right? So I know that you must be knowing Selenium and all that, the new Gherkin and all that new Cucumber, uh, all that new way of testing, and that's an advantage, right? But here you will get to know full stack front to back, plus a machine learning technique, how to do a machine develop a machine learning model full stack front to back, right, in a more rigorous way, right? So that's where your maybe profile and role will be enhanced and quite superior to the confined area where you are working.
Yes, I hope that answers your question, Amol. And then, yeah, so just to add to that, Amol, since you have asked about like the no-cost EMI, of course, team will get in touch with you and discuss. Regarding the EMIs and all those facilities. Of course, we do have a interest-free EMI paying facility if somebody wants. But yes, that's a small kind of your loan process because the application is routed through one of our NBFC partner, Credence being one of them. So you mean in case you want to apply with a EMI options, definitely our team can connect with you and we can discuss and guide you regarding that. Right. So other questions are mostly like of the repetitive. We have already covered most of those questions which are there for the day. One more thing, actually, there are some requests, Sanjay, from people who wants to ask your permission if they can connect with you on LinkedIn. So can we give them permission to connect with you on LinkedIn?
Yeah, absolutely.
Yes, so Girish and others, so those who want to connect with Sanjay on LinkedIn, please feel free to send you connect invite, and yeah, he'll be glad to connect. Right. So Girish, one of the participants asked profiler info, please. So do you does that mean, Girish, that you want his LinkedIn uh, link or something? All right. Okay. So Sanjay, would you be able to share your LinkedIn
So
link
Nitish,
in
yeah,
the
yeah,
chat? Yeah.
yeah. So the deck we circulate, I'll include it there in my intro if that works.
Wonderful. All right.
Yeah.
All right, Girish. So in the PPT that we'll be sharing, we will include Sanjay's LinkedIn link, and you can connect there. Okay. So any further questions from participants? Because the questions we have till now, most of it, like, again, it's like what we have already covered in the other discussions that we have had, right? So if anybody has any other question, then otherwise, maybe we would close the session for the day. just wait for like maybe a few seconds for any other questions. All right. All right. Okay. So if there are no further questions, then maybe we would like to end the session here. I mean, once again, first of all, Sanjay, thank you so much once again for joining. And like, I mean, it's a great session, a lot of insights, informations. Thanks for your patience in answering all the questions. And for the participants, once again, like, thank you so much for joining, taking your time out on a Sunday. It shows your interest in this field. Great to see that enthusiasm and with a lot of questions. So thanks for joining. Keep following up. Keep following us. Actually, okay. Now another question has come. So maybe like we have some time. So let's like see if we can take that up. All right, so it's a question from Saloni, and she has asked actually, sir, do you think credit scorecard will be built completely using machine learning in future? Interesting question.
That's what my current role is. So we are building credit risk scorecards and models using random forest, using many of the boosting algorithms. And the idea behind there is not to adopt them in first place, but to create a challenger model or a benchmark model for our existing models. So our existing models will, for now, for the timing, will stay the statistical, like your logistic regression or probabilistic regression models, which are the typical statistical models based on which these PD, LGD, probability of default or loss given default rating models or scoring models are based, right? But eventually banks are finding a way of proving that machine learning models can do a better job. For that, they are deploying not only typical traditional data set, but many alternative data set. Like you took the example of credit risk scorecard. People in the industry are using a lot of social media scores, right? Whatever you do on social networking sites, like your LinkedIn profiles, your Facebook, right, your Twitter handles, right? They are drawing conclusion through an algorithm, because that's unstructured modern data which a traditional algorithm cannot handle. They're trying to give you, assign your social score or lifestyle score, right? How much you spend on your lifestyle, the pics you post there, right? The trips you go to, right? Sometimes you go to Maldives and you think that it's good to post pictures, but if you have taken credit from a bank, the credit lender is taking note of that, and giving you a lifestyle score. If you are spending too much on your discretionary spend, your CIBIL score or experience score or FICO score will incorporate that lifestyle score and it will go down. Right. So that's the way forward, and obviously it's not new thing. It's happening all across, and most of the things are driven by these Experian, FICO, CIBIL. They are also, the vendors are also developing their models based on machine learning, right? And the banks are also doing the same. The regulator is sitting still a fence sitter. It is still sitting and seeing, maybe if we have enough evidence to prove that these machine learning models can do a better job, right, at predicting the credit worthiness of the counterparty. Yeah.
Yes. So I hope that answers your question, Saloni. Yeah. Thanks so much, Saloni. Great to know that you got your answer. So yeah, I mean, then again, again asking like any other questions. We do have few minutes. I mean, if you have any other specific question. Okay, Amol says that good to know you, Sanjay. I'm also from UBS actually.
Okay, good. Right.
All right. Okay. Right. Fee details of the course, Pradeep. Yeah, I mean, allow us to connect. I mean, offline, but and we'll discuss about the fee details of the various courses on one-on-one. Right. All right. So okay. So any other further questions? So maybe like this time, like allow, I mean, let's wait for like 20-30 minutes, sorry, 20-30 seconds. And then again, before saying that we'll conclude the session, because last, any other question from anyone? Okay, good. So essentially, I think there's no other question. So then again, let's again, I've already thanked enough. So I believe we can end the session for the day. But just before we leave, I mean, as a part of overall IIQF deep dive with our experts webinar series. So we conduct series of webinars every month, once or twice, or sometimes more, and then on various important topics related to machine learning, I mean AI, uh, quant finance, financial engineering, risk management, algorithmic trading, and different advanced analytical areas of finance. So keep following us in our social media pages, in our website, and you'll also receive mailers from us announcing various webinars. So any webinar that interests you, please feel free to register, keep track of us, and we'll be happy to see you in all our future webinars. Right. So with that, we would like to conclude the session. Yeah, I mean, see you again in the next webinar. And yes, Vikas, we will be circulating the PPT to all of you. Allow us like few days time, so will circulate over email. Right. So once again, thanks Sanjay for joining in, and like it was a wonderful session. Saloni also mentions that. Thanks for the wonderful webinar. Thanks Saloni for your kind words. So with that, let's end the session for the day. Thank you.
Cheers, everyone. Have a nice journey. Yeah.
Thank you. Thank you, Sanjay.